Hi everyone. Today I'm gonna talk on how automatic air conditioner works and the new technologies and innovations developed as we proceeded towards smart air conditioning systems. Now, before coming to the automation portion of the air conditioner, let's know air conditioner very briefly. Now, the air conditioner mainly comprises of four basic components. These are evaporator, compressor, condenser, and expansion valve. Now we will come to it one by one. The first thing is evaporator. Now what is it? It is the thing which is placed inside our room. Now its main working function is it exchanges heat. It is filled with refrigerant gas. Now what it does is it takes the heat which is present into the room, and it can just absorb the heat just like a normal water bottle. If we place it inside a heated temperature, the evaporator. Now as the evaporator takes away the it takes away the heat of the room, it sends it to the next component, which is compressor. Now as we can see from the diagram, that there is a piston and there is a rotor. Now rotor means rotating phenomenon is happening inside it, which means actually there is a motor inside it. Now as its name suggests, its function is to compress the air going inside it, and as it compresses the air which is going inside it, its pressure goes on increasing, and as well as temperature also increases. So at the second stage, what happens is that heated air, when it is passed through the compressor, it gets more heated as it is passed through compressor. Now this uh, more heated air passes to the third component, which is condenser. Now this is the thing which is placed at outside of our room, and we can see from here that this is entry point where from the heated gas will take an entry, and these are some narrow and some thin pipes, and this will go on like this, and at the exit, when it will come out, it will be converted into a cold gas, and it will be so much cold that it starts converting into liquid. And why it is placed outside? Because as it is getting cold, so it is releasing the heat. That heat release is done outside, and that heat is released to the surrounding. Now that the liquid which become very cold, which goes to the fourth component, which is called expansion valve. Now this is simply a throttling device. It works on Bernoulli's theorem. As we can see from here, is this is a area which is very high, so high pressure, and this is a low pressure. Low area, we have just throttled it, and it has become low area, and correspondingly the pressure will be low when the fluid will or liquid will pass through it. Now we know a very special property of a liquid, that a liquid can be evaporated into vapor by just reducing the pressure across it, which is the same thing we are doing inside an expansion valve. Now as the pressure goes on decreasing, that liquid which is coming inside it, which from the previous stage, which was condenser, that starts converting into gas, but its temperature is very cold, so this will go out from this bottle, and correspondingly that air vapor which is very cold, which will spread into the room, and correspondingly we will feel the cold. So this is basically the main function of air conditioner. Now there can be other other basic elements also into the system, but no matter which company is developing the air conditioner, this will always consists of this four basic components. Now if we just try to represent the air conditioner in terms of block diagram, then we can see from here that here from the hot air will go inside, and when it will go out, when it will come out from this, it will give me some cold vapor. Now practically this evaporator along with this expansion valve is placed inside the room, and this compression and the condenser, these two are placed outside the room. Now this is the mainly the block diagram of air conditioning. Now let's let's convert that bigger block diagram into some small air conditioner, and we are adding some controlling mechanism into the system. Now, we being an electrical engineer, our main concern is only this portion. This is related to the mechanical engineers and the related domains. Now, as we can see from the diagram, is it's simply a closed loop control system, which is using the feedback element as sensor, and here we have placed the controller, and this is my set point and this is my output. Now the sensor, now the air conditioner will give me the temperature. Now before that, I want to say something, that air conditioner also measures air conditioner also controls temperature as well as humidity, but for simplicity now we are considering that we are going to control the temperature primarily. We'll come into the latter stage the other thing which the air conditioner does. Now let's make it simple. Let's say that we have a set point, let's say 20 degrees centigrade, which we have set using the remote control using the remote. Now, as the air conditioner gives the output in temperature, so it will be passed through sensors, and correspondingly the data signal will be given to the controller, and correspondingly it will give the signal to the air conditioner. Correspondingly we will control the system, control the temperature of the output. Now let's focus on the feedback element, which is sensor. Now, as we said in the beginning, that we are just trying to concentrate only on temperature, so there are these many temperature measuring sensors we can use. These are, you can see from the figure that this is RTD, thermocouple, thermistor, bimetallic strip, thermometer, IR sensor, and semiconductor IC based temperature detectors. Now the question comes here is, which sensor should I use particularly in this automatic control mechanism? Which sensor should I use? Now we can go for RTD, we can go with RTD. The principle behind it is that RTD in this low temperature, when we are trying to control the room temperature, it generally ranges from 0 degree to 50 degree centigrade. So this is a low temperature range, and in this temperature range RTD shows very linear response. Now if this is showing that linear response, so we can use RTD. We could use thermocouple, and we can use even thermocouple also here, but mainly we prefer to use thermocouple when there is a blast furnace, or like some industrial work is going on, or we have to measure some very high temperatures. On that case we require to use thermocouple, because we need at that time we need long distance transmission, and for that if we try to use RTD, so there will be a loss. So on that case thermocouple is the best option. And here thermistor we can also use, and bimetallic strip is not naturally used here. IS sensors are the sensors which we can use, but the problem is here it will not act accurately. Let's, for example, IS sensor is best suitable when we are trying to find out the temperature of a certain object. Let's say, for an example, if the cricket match is going on and there is the hotspot technology which is used into the cricket, so that we just want to know whether the ball has touched the bat or not. At that place IS sensor will act very accurate, because IS sensor, the working principle of IR sensor is simply, if the temperature of some portion is heated, then that high temperature will emit infrared radiations, and there will be infrared detectors. This will detect that temperature, and corresponding there will be signal conditioning circuits. Now when we are trying to control the temperature of a room, we are assuming that in the room it's not like that in one side of the wall it is 20 degrees centigrade, other side of the wall it is 50 degrees centigrade. We are assuming the room temperature is in equilibrium, so we can use here RTD. Now if we require to use, so if we require to measure the temperature of some room where there are placed different objects, and different objects at different temperatures, then we had to go for IR sensors. Now here we can easily go for RTD, and semiconductor IC-based temperature detector are also useful here. In fact, DHT11 is one of the sensors which are available into the market, which can measure temperature as well as humidity. uh, so this is the very popularly used temperature sensor which we normally use into the semiconductor into the feedback circuitry of the control system. Now if we just if we just try to give the explanation how this feedback sensor will work. Now we can see from here that we will use a Whiston bridge. Now this will be a deflection type Whiston bridge, not a null deflection type Whiston bridge, because anyway we need to feed back some voltage, and this will be compared with the set point, and correspondingly we will get the error signal. So we require to use some deflection type Whiston bridge. Now what will happen here is you can see from there that we will use the different temperatures, and correspondingly if the temperature of the RTD goes on increasing, correspondingly the voltage will change, and correspondingly we will control the temperature. Correspondingly we will compare the temperature, and correspondingly the error signal will be given to the controller. The best method can be here, uh, we can use PT100. PT100 is a RTD whose resistance is 100 ohms at 0 degree centigrade, and correspondingly we can place other resistances also 100 ohms, and then correspondingly uh, as the temperature increases, this RTD resistance will increase, and correspondingly we will get the voltage, and this error signal will be given to the controller, which is simply the brain of the circuit. Now uh, there are so many controllers. Now we will come one by one. The first controller is on off control. Now we will naturally try to implement this on off controller into the system, because this is very simple, and this it designed. Now we will simply will we will always try to go for some simple method, so that's why we will try to go for on off control mechanism. Now the on off control mechanism will work fine here, and its design is also not that much complex, but the problem with it is, let's say the set point is 20 degrees centigrade and the room temperature is 24 degree. So the controller will be given the signal to compressor, and controller will give the signal to compressor that the motor should rotate, and correspondingly it will rotate so that until the temperature reaches 20 degree. Now as it goes on rotating, as it goes on rotating, and as the 20 degree centigrade is reached, and 20 degree centigrade or 90 degree centigrade is reached, correspondingly the controller will off, and then again as the controller off, the compressor gets off, and correspondingly there will be no mechanism of producing cool air into the room, and correspondingly the temperature can increase. So we can see from the system that the system may oscillate very frequently. So that is a problem with on off controller. But as the temperature is very slow variable, so we can use on off controller, and it will not create that much problem. Now next, as there is a problem happening into the on off control mechanism, people starts moving towards continuous control mechanisms, and which is simply PID control mechanism. Now what happens inside the P controller is, we can use a P controller here, but the problem with P controller is that we need to set a manual bias here, and we cannot make the offset error 0. So that is the problem with with the P controller. And as we can see from the diagram here, that if this is a P controller, now if the error signal is 0, correspondingly the output will be 0 and the system will turn off. On the other words, if we are using P controller here, then we cannot get the error 0 here. We cannot get the error 0 here, and we will get always an error. Now to reduce that error, people started going towards eye control mechanism. So the problem was not in PI controllers. The PI controllers is a good thing, but the problem with PI controllers here is the temperature is a slow variable. Now if we see this diagram, this is a diagram. This is my set point. I have written it et, but this should be set point. I have written it mistakenly. Now this is two process going on. This is a fast process, this is a slow process. Now you can see from the diagram is, if the process is very fast, so it will reach the set point very fast, and correspondingly the shaded area we can see from here, this is actually the integration, this is actually the control output, which will be the ki into integration over etdt, uh, which is representing the shaded area. So we can see from this diagram is that if the process is very slow, so it will take more time, and correspondingly this shaded area will go on increasing. That means the control output will go on increasing for slow variable. Now if the control output is going on increasing, so it is directly connected to actuator, but actuator cannot go to the infinite, and it will lead to some actuator saturation. So that is a problem with PI controllers. Now to reduce this action, we can go for anti-integral wind up, and there is a very famous method called back calculation, where we use feedback between actuator and controller, so that we do not allow the actuator to reach its 100%, and we don't allow the actuator to reach its saturation. Now PT controllers can work fine here, but the problem is that we cannot completely vanish the integral component, because as we can see from the diagram is if let's say et is equal to 0 at steady state, that is the thing which we desire, the error signal should be 0, and if et is 0, we can see that this will go 0 and this will go 0, and the ut will be given solely from this integral output. So due to the actuator saturation which is going on, we cannot just simply remove this integral portion. What we can do is, we can go with preferably less ki, or we can use some anti-integral reset wind up circuits. So that is the method of PD controlling, or otherwise we can use PD controller, so that will also work fine. Now one thing I like to mention over here is, no engineering design is perfect. Whatever we are trying to do, we are just trying to optimize the system, and nothing comes for free. So now we normally prefer PID controller, because PID controller is very easy to implement, they're very easy to understand, and its working is simple. But there are also other controllers available into the market, one of which is fuzzy logic based controller. Now as we are going into fuzzy logic, so that means we are incorporating in artificial intelligence into the system, which is actually the beginning of our smart ACs. Now we can see from here that the air conditioner which implements fuzzy logic as controller can significantly reduce energy consumption. So that is the main reason we will go for fuzzy logic based controller. Now the fuzzy toolbox means, in the fuzzy logic there are two types of inferences possible: Mamdani type inference and Sugeno type inference. And Mamdani type approach follows linguistic mathematical modeling, which actually means we are just defining variables in terms of what, let's say very hot, and correspondingly it will defined by different membership functions. I'm coming to that. It will be easy to explain with an example. So before that, this is the fuzzy controller block diagram. Now what happens here is, in fuzzy logic the output of the system is evaluated based on the system's input output. The input are fuzzified by using these fuzzifications, and we can go for triangular membership functions and also Gaussian membership functions. I'm coming to that thing. But the next thing is, then we will set some rules which will be set by us, corresponding to the different rules. It will give the inference, and the output from the inference block diagram will be some fuzzified value, that will be called a fuzzified value, and then it will be passed through some defuzzification, There are so many methods of defacifications available, mean max method of defacification and center average using singleton value defacification method. There are so many defacification methods, and when it will come out from the defacification block, it will give me crisp output. Now the crisp output will be a real variable. Now let's come to an example. Let's suppose we are going to control the temperature. We are going to control the temperature as well as the relative humidity of an air conditioner. So what we'll do in our fuzzy logic based controller is, there will be two inputs, temperature and uh, relative humidity, and the output will be power applied to compressor. And then we will set some rules, and we will give corresponding to the rules, we will the controller will take different inferences. I'm coming to that thing, but before that we need to explain this thing. Now let's say we are trying to control the temperature of a room whose temperature ranges from -5 degree to 50 degree centigrade 55 degree centigrade, sorry. And the relative humidity is, as it is expressed into percentage, so it is varying between 0 to 100. Now what we are defining is, uh, the range between -5 to 10 degree, it is defined as very cold temperature. The range between -5 to 25 degree, it is defined as cold temperature. Range between 10 to 40 degree, this is defined as warm temperature. Now these are these triangular things, whatever we are seeing from this diagram, these are called actually the membership function. Now if the temperature is 25 degrees centigrade, we will call the temperature to be warm. So that is actually the meaning of that linguistic variable which we are talking, because the linguistic variable means the warm, and corresponding its mathematical value is coming out to be 25 degrees centigrade. So these in this way we have divided the temperature into 5 zones, and we have divided the relative humidity into 5 zones: very dry, normal, wet, and very wet. And correspondingly this is different membership functions. Now this is triangular, this can be Gaussian also, and there is no necessity like it should have some symmetry, as in the diagram it is drawn symmetry. This is due to this is just to make the calculations easy, but it doesn't mean that we have to go with this symmetry. It can be possible that one temperature goes from 10 degree to 30 for 10 degree to 30 degree instead of 40 degree. So it depends from temperature to it depends from controller to controller, and the way we are trying to control over it. Now in this way we will define two membership functions, to 5 to 5 two membership function, and then we will set some rules. Now these are our rules. As we can see from the diagram or from the table, this is in this direction we are placing the relative humidity, and this is temperature. Now we know that if the temperature is very hot, the motor of the air conditioner compressor should rotate at high speed, and to the temperature, and when the temperature goes on decreasing and when the temperature is very low, the compressor should run low. On basis of that rule we have defined this rule. Now this is the rule, and correspondingly we will get the output. Now the thing is that, as we said here, the output is the power applied to the compressor, and power is assumed to be varying between 0 watt to 200 watt, and that 0 to 200 watt is also being divided into 5 things, similarly like these two membership functions, because we will just try to we will not try to increase the complexity. We can go for that will require some tedious mathematical calculations, but for simplicity we are assuming we are doing it, that power range is also from the output. There will be also a membership function that will vary from 0 watt to 200 watt, and this is divided into 5 category. These are high, normal, very low, very high, and low. So these are the 5 range, and correspondingly we have defined it similarly, exactly similar to this way, the way we have drawn it here. Now let's suppose the temperature of the room is 30 degrees centigrade and its relative humidity is 32%. So if the temperature is 30 degrees centigrade, so it will come inside the warm box, and it will also come within the hot. And if the relative humidity is 32%, so this will come inside this normal humidity range, and also this will come inside the dry humidity range. So these are my membership function values, which will be passed through defuzzifier. And there are so many methods available for defuzzification. Now if we use min max defuzzification method, and min max defuzzification method corresponding to these rules, and we will use some rule. I'm not going into that detail, otherwise it will we will move from the topic. So it will give some what, and I have calculated this is coming out to be 124 watt. This is coming out to be 124 watt. If the relative humidity is 32%, and the temperature is 30 degrees centigrade, corresponding power I should apply to compressor is 124 watt out of 200. So this can be a method to control the air conditioner. Now, till now what we are doing is we were trying to implement automation, but what we couldn't do is we couldn't make the set point automatic. Now what we are doing till now, we were just making we are just setting the set point, which is simply the controlling of remote, that 20 degrees centigrade or 24 degrees centigrade. So that was the problem which is happening with us, but this is genuinely a problem, because that temperature zone which we are comfortable, that changes from person to person. So still there are so many ideas going on, like we can use infrared camera, which can be used to detect user body temperature. To implement this thing, what we will require to do, the system will require the person to stand in the fixed place, and so that it can capture its image, and then it will apply some digital image processing, and correspondingly it will find out the person's comfortable temperature, and correspondingly the set point will be given to that given to that comfortable temperature. And in that way we will not require to use the remote frequently. Another method can be such that we design a system which can detect weather conditions and correspondingly change the set point. Now this is a very good method. What we require to do here is we need to find out whether it's a rainy season going on, or whether it is summer going on, or winter going on, and correspondingly we will require to use another fuzzy controller. So the diagram will be like simply like this, and there we will require three input variables. Two input variables are there, temperature and relative humidity. The third input variable will be brightness, and we will place this brightness sensor outside the room, so that it can capture the brightness, and correspondingly it will detect the correspondingly so that it can detect the season. Now again we will go for fuzzy logic. We will defuzzifier, and then here from output we will get some crisp value. The crisp output will be here the comfortable temperature, which will be calculated by this fuzzification methods. And this fuzzy controller we will use, we can get a set point, we can get a temperature which is a comfortable temperature. Now that comfortable temperature will be applied to my set point, and correspondingly you can identify from this that this is the previous diagram. And in this way the automatic air conditioning can take place. This is actually the uh, diagram of smart AC, where what we can implement into the system. Now what it will do, it will significantly reduce the use of remote, and correspondingly we will not require to use the remote, and as the season changes, correspondingly the set point will keep on changing. So this can be a method of automatic setting of our set point. The last thing is comparator and actuator, the two remaining block diagrams what I just skipped. Now here as a comparator we can use normal open loop op amp, we will not require to use OTA, means operational transconductance amplifier, OTA, or a CMOS based comparator. We will not require, because we are not going to operate with the high frequency, as temperature is a very slow variable, so it will not be varying frequently. So we can simply go with open loop op-amp. Of course there will be a problem of offset, but we can reduce it by using different offset minimization techniques, and it will work fine. And lastly, as an actuation system, here we can use pneumatic or hydraulic actuation system. These two will work fine. That's all. Thank you.